So thank you, Sarah. Now, often in ICAO events, we have a paper or electronic survey that we provide to everybody so that you can give us feedback. We're not doing that this time. Instead, we want to make use of the feature on the RPAS app. So as long as you have the app downloaded, you can go in and rate all the different sessions. If you really want to spend a lot of time on it, you can go in to individuals and rate them. But if you would rate the sessions, we would be quite appreciative. Now, yesterday, we focused on licensing and competency-based training and assessment, and its application for remote pilots. What CBT means to operators with different operational scenarios, and also to the licensing authority inspectors. We also looked at things from the operator's perspective, both in terms of training of staff, as well as for planning and conducting safe operations. So today we will be taking a bigger, broader view of the whole scenario. We'll start with the ATM environment, followed by the aviation system as a whole. And then we'll finish the day, as well as the symposium, by looking out at what's coming next. Now, to lead us into the discussion on the ATM environment, we've invited Mr. Chris Dalton, Chief of the Airspace Management and Organization Section here in the ICAO Air Navigation Bureau. Chris has been at ICAO for 21 years and worked as an air traffic controller in a previous life. He was also my mentor when I arrived here as an ATM technical officer 10 years ago, so I learned a whole lot from him along the way. Now, when we get to the end of the session, actually not just the end of the session, but during the session as well, if you want to be posting any questions to the panelists, remember we have the email address plenary@icao.int. So as questions come to mind, go ahead, email them into us, and Chris will have great fun posing them to our panelists. All right. Good morning, everyone.
Good morning, everyone. And so I'm Chris Dalton, Chief of the Airspace Management and Optimization Section. I know it's a terrible name. A previous boss of mine changed my name from Air Traffic Management. Apparently that was too complicated. And so it's now the AMO section, which also stands for Approved Maintenance Organisation. So you can imagine how much fun I have with all those sorts of names. We've got a wonderful panel for you this morning. Normally when I do the pre-statements on who they are, you want to keep it pretty brief because I think you know most of them. But when I read through their CVs, these people are a fantastic panel, so I was very pleased to get them. But just as a precursor to the quick presentations that we're going to have, and then we're going to have plenty of time for discussion, I just want to recall a few things from within this organization. Understanding that the ATM world is designed to be flexible. So I don't know how many of you are familiar with what the definition is of a flight information region. The whole world is split with boundaries between states across oceanic areas, and these areas are called FIRs, Flight Information Regions. And a flight information region is where a state will be either delegated or take responsibility for the provision of air traffic services within that FIR. So the definition is an airspace of defined dimensions to provide a flight information service and an alerting service. You don't even have to provide air traffic control. You don't have to even provide radar. That came later, or will come later. So it's up to a state in consultation with their users to determine what kind of service you're going to provide. And actually, in some parts of the world, that's all you do get, is a flight information service. Over Somalia, the comms are so bad that basically all they can provide right now is a flight information service. In other areas, you've got radar services, you've got formal separation between aircraft. So there's a lot of determination of risk and discussion with the users of that airspace to determine where they're going to go. And when you get new users, new entrants coming in, you then have to review whether or not those services need to be changed yet again. So we have those basic building blocks, a flight information service and an alerting service, and from that we look at risk and see whether or not we need to upgrade that service. So many years ago we had these things called unmanned free balloons. That was our colleagues in the weather department sending off these huge balloons. No one really knew where they went. No one really knew how high they went. You know, maybe they all collected somewhere and just stayed up there. I had no idea. But it was understood that no one really knew where they were, so there was going to be no air traffic control service, maybe a little bit of traffic information, but that was it. So there was guidance put in into the ICAO annexes and manuals, which says you don't need to provide separation with these balloons. Why? Because we can't. Now we've got other kinds of balloons. We've got Google Loon balloons, and they've got ADS-B transponders on board, and we know where they are every half a second. So there's no problem if we wanted to provide separation or a better service. Plus the risk is much increased because there could be thousands of them one day. So now we have a panel in ICAO, the Separations and Airspace Safety Panel, which is developing provisions and guidance on how to provide separation against those particular new entrants. So constantly we're changing and we're looking at our provisions and how they apply to a new environment. A day before I even arrived in ICAO, it was decided the best thing to do was change the definition of aircraft. That was the best way of providing a service to the community so that the providers of services could go away and do that sort of service. So when we ask ourselves a simple question like, will the C2 link ever be as robust and instantaneous as the onboard pilot communication, you are joining a fantastic journey of aviation discovery that started a long time ago, and you play an important role as we move forward. I'd like to introduce my first speaker. Now, this guy, air traffic controller, you could just say just an air traffic controller, but this guy was a London area and terminal radar controller. So we're not mucking around here. This guy knows what he's doing. 20 years as an air traffic controller, worked both in civil and military aircraft in the UK and overseas, so has a full experience in different regions, and he's now the IFATCA nominated member of RPAS, and he's also a member of the ICAO UAS advisory group on drones and UTM. So I'd like to introduce Rob Stallard. Rob.
Thank you for the introduction, Chris, and good morning, ladies and gentlemen. Thank you for having me here today to discuss the topic we're discussing. What does the introduction of RPAS mean to the ATM environment? And I'm going to look at this from the perspective of perhaps the most important aspect of the ATM system, and that's the tens of thousands of air traffic controllers that we have around the world that ensure that we have a safe and efficient aviation system. The two things in particular that I want to focus on are the concept of change, that is change within the ATM system and how that's going to be felt by air traffic controllers, and also questions, the fact that we have many, many questions still to answer, many questions that we probably haven't even asked yet when it comes to really understanding the impact of RPAS on our ATM system. But I first wanted to start with a little anecdote and a question about air traffic controllers and change. I was visiting the remote tower in Sundsvall, Sweden last year, which is a very interesting concept that many of you will be aware of. Remote air traffic services very much aligned to RPAS. And a fellow London controller gave me this little anecdote which I thought was quite relevant for today. Essentially, you have a room full of air traffic controllers. You nominate a spokesman amongst them, probably supervisor, and you ask them collectively a question: how many of you guys and girls is it going to take to change a light bulb? So the first answer is stand by, always stand by. And then eventually they come together and they come back with a response, and the response is change. What do you mean by change? The implication being that they don't understand what change is, and therefore they can't answer the question. So for me, that's really interesting, because as a controller, I think sometimes our self-perception and the perception of the controller community is that sometimes we're perhaps not enabled for change, or not as signed up for change as perhaps we should be. And I think also this anecdote is relevant because the answer is not an answer, it's another question. And as many questions as we seem to answer for RPAS, we generate even more ourselves. So looking at the ATCO's view of change in regards to the impact on our ATM system of remotely piloted aircraft systems, is it fair to say, back to our scenario, that generally air traffic controllers are against change by default? I don't believe so. Daily tactical and operational changes are commonplace and really the bedrock of what we do in air traffic control. But I think perhaps the reason the perception about our ability to change exists is that we have to understand that fundamental change in worldwide ATM has rarely, if ever, happened. And if we think about the huge changes in our everyday lives, of communication, the internet, and such things, that's happened in our outside lives, but yet in ATM, it's often said that we're still really looking at an infrastructure that was developed in the 1950s and 60s, and certainly the analogy of driving modern cars on roads that perhaps had not been updated since that time is quite apt. So in ATM, we've not had our digital revolution moment yet, I don't think, but I think that we soon will. As we look at the global air navigation plan and the aviation system block upgrades, I think there's a natural move towards a much greater data-driven ATM system, and perhaps an opportunity for RPAS downstream to tie in with that. The controller-pilot relationship, I think, will change with RPAS, and I think it's important to understand that fundamentally air traffic control is about somebody on the ground looking after somebody in the air. It's a very altruistic profession. Air traffic controllers are proud that they, by what they do on the ground, keeps people in the air safe. But now we're sort of kind of changing that, because we're now having aircraft with no person on board. At the end of the day, we have to remember that although I'm sure our pilot friends wouldn't admit it, it was them that started air traffic control, for the very reason that it was to keep them and their colleagues safe in the air, with an infrastructure and a capability that's delivered on the ground. So I think I don't have an answer to that. It's one of the many questions. Is we'd have to be very careful that we don't subconsciously change the way air traffic controllers look at their profession, look at what they do, and guard against RPAS potentially becoming a sort of second-class citizen within the system, because there is nobody on board to look after in the air. In terms of seamless integration, if RPAS are going to be seamlessly integrated within the ATM system, then that would be great. If it was completely seamless, then we wouldn't be having all these discussions. But we know that that can't be the case. We can't have a 100% seamless integration. So the real question here is, how far in reality will RPAS be able to comply? Will the system have to change? And how much will we need to be prepared to let our air traffic management system change to accommodate remotely piloted aircraft systems? This is especially the case for contingency plans and unusual situations. For example, lost link encounters and RPAS airframe emergencies. These, I think, are potentially huge issues for the ATM system to address, and we must really guard against transferring any risk to the air traffic controllers to address any inherent weaknesses that are otherwise present in the system. In terms of duty of care, with no pilot on board an RPA, then the very concept of safety, as I've mentioned before, the pilot-controller relationship, but also the duty of care concept, which many legal systems around the world champion, is going to change. Even if you were to look at the ICAO definitions for urgency and distress, PAN and Mayday, there's some questions in there about could they really, in some cases, apply to an RPAS, to the actual aircraft, where there's no person on board, there's no threat, there can be no danger, there's no human life. And during my career, I've had several occasions where I've been a manager of the airport firefighting and rescue services, and it's interesting to perhaps look at how they approach things. When they're approaching an aircraft or a building, one of the first things they ask themselves is their life on board? You know, is their life inside? Is their life worth risking our lives to go and save? And I think there is an analogy there for air traffic controllers in how we look at RPAS. The duty of care concept, many legal systems in the UK have this concept of duty of care, which is a big concern for air traffic controllers right now. So in spite of any written regulation, any guidance, or any other material, there is a legal duty to foresee and prevent injury and loss of life. So adding an unmanned aircraft into a complex set of procedures, priorities, potential confusion, and the ability potentially to have life-saving decisions made by the controller in an emergency situation does give cause for concern. And I think this aspect in particular will need guidance with respect to legal responsibilities that will need to be crystal clear for the air traffic control community to be able to accept RPAS into the ATM system. It also goes without saying that human factors and training considerations should be considered from the outset. I know we had discussions yesterday on training, but really we would encourage that the requirement to train air traffic controllers is by design from the outset rather than an afterthought, a bolt-on to the whole process. If you start the training requirements and design early, then it's a better journey for all those involved rather than an afterthought, which we do see sometimes in air traffic control. And then the other part of my presentation quickly is questions and more questions, and the ultimate question, I suppose, what if? Now, air traffic controllers are a cautious bunch, but they are also a vast source of expertise and problem solving. And we would really encourage all of those of you in the RPAS world to use them to your advantage and get them involved. I guarantee they will generate some very awkward questions, but they will also help you to solve them. And it is vital that training is offered at that early stage, as I previously mentioned, to allow the kind of questions that we haven't even thought about yet being raised. Within the RPAS panel, certainly in the ATM group, I think for every question we answer, we probably generate 2 more questions. And sometimes ones we think we've answered, we go back and change our mind as a result of discussions or things that have happened out in the real world of RPAS. So in conclusion, this is a once-in-a-generation change to our ATM system, which we can't take lightly. We've got to get it right to ensure the continuity of safe and efficient air traffic management worldwide. And thank you for your time. I'm happy to take any questions.
Thanks very much, Rob. Actually, you commented on something that my boss, Steve Creamer, often reflects upon, in that as much as air traffic controllers can be problematic in asking the questions, it's often the operational people. We're talking about pilots, air traffic controllers, and those people that actually work on the airport who will be able to define the problem, but also go further and offer solutions from their experience. Nevertheless, if you look at some industries around the world, and I look at something like Uber as an example, in redefining how we have taxi services, the people who redefined that industry came from outside the industry altogether. So I'm wondering whether or not my next speaker will reflect upon that. His name is Rob Eagles. It's kind of embarrassing to give an introduction to him. Everyone knows him. They're aware of his criminal record, which is that he works for the International Air Transport Association. He's the director in charge of ATM infrastructure. headquartered here in Montreal. In his role, he is responsible for all new concepts of operation and technology related to airspace and air traffic management operations, and a primary focus of this work is the safe and efficient integration and operation of RPAS. Prior to this role, Rob served as the IATA Regional Director in the Asia Pacific region, which gives him a good insight into one of the biggest growth areas for traffic, whether or not we have RPAS involved or not. Thank you very much, Rob.
Okay, thank you, Chris, and ladies and gentlemen, a very good morning to all of you. So some thoughts and hopefully some topics for discussion in relation to the evolving business of unmanned vehicles. So RPAS UAS, I think we would all agree that the growth and scope in this new aviation area is exceptional. Small to large aircraft, low to high altitude operations using new and advanced and evolving technology to conduct basic to highly complex, again, evolving operations. So as Chris just mentioned there, we have new aviation actors. And the new aviation actors are really positive of bringing to aviation new thinking, new technology, significant and new investment, and also a new way of doing things. So we have somewhat this converging paths of manned aviation and unmanned aviation. And to help understand what key considerations we need to give to the future, IATA and NASA brought together new entrants and established aviation for 1.5 days over the summer to discuss the topic. The manned aviation being airlines, ANSPs, and from the new entrant side, we had low altitude, high altitude, and actually commercial space operations as well. I just want to give you a very high-level overview of some of the key takeaways from this meeting. So the current system, there's going to be a complete new element of diversity being brought into the national airspace structures around the world. And that current system today doesn't deal with diversity very well. We also need to consider scalability within the future system to allow new entrants to be integrated appropriately, effectively, and then expand with respect to scalability based upon their business models, often aggressive business models. We need to clearly define, to set the foundation, concepts of operations for new entrants, in particular, low altitude and high altitude. Some of the key foundations for the future operating system. Federation will be key. Federation where everyone is speaking the same language. And automation will be another founding principle to enable the safe and efficient mass operation of vehicles. Obviously, as we're here, from an international perspective, we need to look at rules and definitions, in particular, low altitude, below 500 feet, high altitude, flight level 600 and above. From the ATM side, we will need, and there will be a requirement for new thinking, new business models, new way of operating. Regulatory framework needs to be speeded up to keep pace with technology. What are the required services for the future operating system? How do we actually do aircraft separation and service provision? Planning coordination is key to enable this diversity to be accommodated safely, and contingency in relation to business models needs to be considered. The operations that will be introduced in the future should, potentially, but should include vehicle-to-vehicle communication, self-separation, and different focus on actually how we manage traffic strategically and tactically. There's a real opportunity for transferable concepts of operations and technologies. But, as ever, we need a harmonized global approach, and I personally think that the GANIS meeting later this year, Global Air Navigation Industry Symposium, there will be a key discussion required to look at the applicability of the aviation system block upgrades and the Global Air Navigation Plan to accommodate and be able to evolve as new entrants join the marketplace. So within IATA, we took a little bit of a liberty, and we did a SWOT analysis. I'm sure you're all familiar with the SWOT analysis, looking at the strengths, weaknesses, opportunities, and threats. And we changed the word threats to risks associated with where we are today, and actually what will be the key considerations going forward with respect to evolving operations for all operators. So the strengths. I think we'll all agree today the safety standards of manned aviation is something to be proud of and is reflected in our safety record. And also within this SWOT analysis we can include airports. So ANSPs, and airspace users and airports generally, we have a good relationship. Yes, there's lots of challenges, but we have a good relationship and we work together. Some of the weaknesses. Are we fast enough for the RPAS UAS industry? We have different thinking than new entrants. And do we have the bandwidth and capability to develop new solutions? Can we bring that capability and manpower to bear to keep up and actually get ahead of the dialogue? But there are significant opportunities ahead. We can change airspace operations, and I touched on that on the previous slide. Huge opportunity for transferable technology. We're entering a new arena for aviation, and we have accessibility to new and different thinking. But there are some risks. Safety, which is my organization's #1 priority, must always be the key consideration. The speed of change is a risk and needs to be considered. Also, within the established aviation community, there is a lack of awareness. Every time I'm talking to new operators or new businesses, I'm always learning something. It's fascinating, but also we need to be conscious of that as we move forward. We have disparate efforts as an industry with all the different associations, all the different organizations. We need to ensure we have a common focus moving forward. Regulation, there's a risk here that regulation is actually based on pressure. And we need to be sure that we always have a fair and equitable access to airspace. And also, we must also consider and avoid dominant entities with funding, manpower, advocacy can actually dictate solutions in certain situations. We need to embrace new thinking as we move forward. So getting a little bit more specific on the air traffic management side, it is a foundation and a critical component for obviously the airspace operation today and as we move forward. The RPAS panel is focusing on the IFR work for international operations, and we've heard a lot about that in these previous days. But also, we should clearly understand now that UTM, U-Space, will have a significant influence on ATM. As I've already mentioned, transferable technology, new concepts of operation that can be applicable from unmanned vehicles to manned vehicles. The worlds will meet, especially around the focus of automating ATM, perhaps a stepping stone to more of the UTM concepts which are being proposed at the moment. And a key influencer which will drive the focus of the decision in which the business and industry goes will be the economics of how all of this works. In particular, the investment and charging. What new business models are going to be used? Already there's some very new thinking and clear thinking on how the business models for UTM will work. And there's huge potential there to actually transfer some of that thinking into the established ATM, ANSP, CAA models today to make it more efficient and more cost effective. Who pays? Where's the funding? Where's the investment coming from? What are the charging principles associated with unmanned vehicles? What criteria do we use? And as recently as a couple of months ago, a new working group was established within the Airport Economics and Air Navigation panel to address this. But will they be able to keep up? And what models are being looked at today by private industry? And some of them are extremely interesting. On the service provision side, the US has been very clear. It'll be third-party service provision for UTM. But how will CAAs and how will ANSPs, what decisions will they make in relation to service provision? And I suspect a lot of it will be based upon the investment and the economics of recovering that investment. Just want to quickly touch on regulations because obviously that's been a theme as we've gone through the last couple of days. There's significant political pressure and social pressure in some areas for the introduction of RPAS and UAS, and that's to be expected. We're moving forward with a risk-based approach for regulation, very appropriate, and it's something that the manned aviation world has transitioned into and is very eager for it to expand because of its efficiencies. But future regulations, we've got a complete new element of manufacturing coming into the arena that have more agility and a significant capability to provide data at accelerated rates which we've never seen before in aviation. There's a huge technology component associated with this, but we need to focus on the agnostic capabilities, and a performance requirement for all airspace user. Or to say the manufacturing is very fast-paced, so the regulations need to keep up with the technology capability as that develops. And I suspect there's going to be various different technology capabilities associated with different UTM models around the world. So how do we ensure a lot of the investment that's actually going into that area and how it's paid for is not redundant as technology advances past what the implemented operations are? And also, what about regulation for the manufacturers? This is going to be a key component, is already being discussed on the IFR side, but as the UTM system expands and gets closer and is integrated and overlaps with the ATM system, we need to start looking at that from the manufacturer's capability as soon as possible. And on that point, we need to be careful. Pure engineering solutions are being looked at the moment, but may not necessarily be the answer. And there's an awful lot of dialogue within ICAO at the moment on the RPAS IFR work in relation to how do we manage the transition as we're introducing new technology and mixing it with all of the components that have to be considered in various annexes. Detect and avoid being a real hot topic. Finally, the ICAO role and their speed of processes. I think ICAO will acknowledge, and they are acknowledging publicly, that they have to look very closely at their own capabilities internally with respect to them still, where appropriate, defining standards for UAS, whether it be high altitude, low altitude, and the IFR operations, to ensure we can move forward effectively from a business perspective and obviously from a safety perspective. So, ladies and gentlemen, thank you very much for listening. I've kept it pretty high level deliberately. We are entering uncharted territory, but it's exciting, it's challenging. There will be significant challenges, but also from the IATA perspective, we also consider there are significant opportunities that lay ahead as well. Thank you very much.
Thank you very much, Rob. Yes, the role of ICAO. We do need to remind ourselves sometimes of why we're here and what are our primary responsibilities. ICAO is not expected to solve all the problems of the world, and we have a very clear mandate. I think that's something often ICAO panels need to be reminded of occasionally, that we don't go into areas where perhaps other organisations and other parts of the community are better situated for solving those problems. I would have to say, in my experience, the biggest complaint we've had in ICAO over the years for the standards that we have produced and have been adopted by the ICAO Council, most of the complaints that we have had is because ICAO moves too quickly, not that we move too slowly. States are not prepared to implement those regulations, and our safety oversight audit program tells us that. So I think we need to keep that in mind as well. We could be really, really fast. It may not make a difference. It now gives me pleasure to introduce Doug Davis. I could say bigger than life, but let me just read this out. So he's director of the Office of, this is a worse name than mine, Office of Independent Airworthiness, Research, Technology, Engineering and Everything at Northrop Grumman Aerospace Systems, where he leads all aspects of airworthiness support in the aerospace systems sector. He is also responsible for flight certification for all manned and unmanned aircraft programs. I have no idea how you got here, just saying. And probably your phone is ringing right now. Doug is the CANSO nominated member on the RPAS panel. He's also chairing the ICAO UAS advisory group and was recently elected to be the vice chairman of the CANSO Operations Steering Committee and currently chairs the AIA UAS Committee. Thank you for coming, Doug.
Thank you, Chris, and thank you to the ICAO team for inviting me to be on this stage this morning. I know how much of a journey that is for the team, given everything else that they've got on their plate to do. Leslie and her team, thanks very much. So, in the midst of all that bio stuff as well, along with a lot of my colleagues on this stage, I also spent some time being an air traffic controller as well. So I'm not an engineer. Don't ask me how I became an airworthiness director. It's a different journey. But I pride myself on being an air traffic controller first and understanding the airspace system. And I think that that is one of the things that's important in this dialogue. When we talk about introducing RPAS to the ATM environment, that's a loaded question. So let's talk about it. But first, let me pay my homage to the organization that brought me here, which is CANSO. I just want to flip through these. I'm sure you'll get copies of these slides, right? They're being made available. So you've seen these before. CANSO is a very well earmarked organization in making their stand globally, and in particular for RPAS, which I'm appreciative of. These are some of the things that we are partnering with ICAO and IATA. And then some of the, in particular, the RPAS and Emerging Technologies Work Group, which I'm happy to chair with Randy Willis from the FAA, some of the things that we're both have accomplished and are currently working on. So when we talk about introduction of RPAS into ATM, we're still faced to some degree with a lot of the same questions that we've had for the past 10 or 15 years working this. And I think resoundingly we can say that RPAS have challenged our current traditions. Okay, we got that. Let's move on now, all right? So part of our inability to be able to move on has been laid at the feet of the manufacturers, and I think we need to own it. The manufacturers and operators. When we start to say that we haven't done a very good job of communicating the crossover benefit of unmanned technology to manned technology, I think that again is an understatement. I think that we're not winning over the manned aviation community or the pilot community by and large because of that lack of consistent ability to be able to communicate that message. So part of that to me is in this second bullet. Is there a common understanding of the technical capability that RPAS can and will bring? And when you start to talk about ATM and that introduction, then it becomes clear to me that no, there is no common understanding about what the capabilities are that are going to come. And largely it's because the development of the standards, part of which are taking place here at ICAO and the RPAS panel, is still ongoing. It's still a moving proposition. So consequently, we haven't seen many type certificates. We haven't seen many TSO'd boxes, aviation equipment that are specific to RPAS become commonplace in the system, which is part of our tradition in this aviation community. So consequently, we haven't seen a direct correlation to that technical laydown, right, to show up in an operational capability where you can do prediction. It just hasn't happened yet. It's coming. But when it does get here, what are the opportunities that are there, in particular for ATM? Right, from my perspective, what we're seeing a lot of, and they don't make the headlines as much as detect and avoid. I think that everyone in the group, in the room, will probably acknowledge with me, maybe I'm assuming too much, but when we get a type certified or a certificated collision avoidance system, a mature one, for RPAS and unmanned technology, that should shock the world, at least from a manned aviation community as well. Because my mindset, because of when I was in the FAA, always goes back to the Payne Stewart event, right? When somebody's not on the airplane because they're incapacitated, and there's a potential now for ground control capability or on-aircraft capability to be able to take over the flight, rescue the flight, restore it, and make it land safely, to include avoiding collisions, those kinds of things. I mean, that's your billboard capability, right? So there's opportunity for that. But what I call the fringe capabilities, look, from an ATM perspective, RPAS are bringing a data management capability like we've never seen before. There's a ton of data going up and down into the atmosphere. There is. Opportunity is there on how you can control that, manage that, move things ahead. We talk about 4D trajectory, right? Opportunities like that, where you're going to have better prescribed, I mean, our friends in RMP love this, right, and RNF, because of the ability to do tighter things, do more manageable, more ATM efficient prospects. And NextGen and CESAR JU, RPAS, we felt like this for 10 or 15 years already. If you need a platform to justify and bring next-gen and SAES RJU to a reality, look at RPAS, right? Because they're going to have the ability to predictably, in an automated fashion, do things in a way that can hit the mark every time, right? Safety is first. It has to be. But one of the things that we get questioned routinely is, well, how safe is safe enough? And what is that based on? Is it based on 100 years of legacy in our aviation system, or is it based on tried and true processes and tools? So are we as a community, I would ask, are we really interested in exploring new ways to make the system safe? Right. So as we look to the future, I hate to use this word autonomy because 9 times out of 10, everybody has a different meaning for it. All right. But and when we're talking about today's systems, we're largely talking about complex automation, right? And the thing from an ATM perspective that is so important with this, the criticality is the predictability for air traffic control, for ANSPs. The more we integrate complex automation into the aviation system, the more our system becomes effective and predictable, which is important for the way we move forward. But one of the things that we still are struggling with is how do we certify autonomy, right? And that the aspect of that in today's system, developing a path for certification to autonomy, is it going to be affordable, right? I think, and this was something that Chris or Rob mentioned, I forget about the affordability. But the bigger question to me too is, can we integrate, we're in accommodation period right now, can we integrate RPAS in such a way with complex automation where we are improving safety? It's hands down, yes, there's a way we can do it, in my opinion. But the sub-bullet to that is, how do we prove it? How do you prove that you're making it safety? And all that to lead to the last bullet from my point, where I think that we need to have a dialogue in the community. And that is, we're bringing a lot of complex automation, potential for autonomy, phases of autonomy, whatever you want to call these things. But shouldn't we also bring along safety risk management and the tools that go along with that, so that we can justify to air navigation service providers, air traffic management people, that we have in fact made the overall system safer, and here are the tools to prove it, especially once we lay down what that technical path is. And I believe that that was my get off the stage side. Thanks very much. Look forward to the questions.
Thank you very much, Doug, and a lot of food for thought there, and most of my comments will be related to my questions on your presentation. It's all about taking ownership by states, by manufacturers. Remember, ICAO really, I got to keep my voice down here. ICAO doesn't really lead. We steal stuff. We steal good ideas from things that are happening out there. Can you imagine if ICAO just came out with a new concept that no one had ever tried anywhere in the world and says, this is what you're going to do? That's not going to happen. What we're going to see is there's going to be certain leaders out there, the manufacturers, the states, the regulators, that are going to try something out there, and it's going to work. It's going to look quite good. And then within ICAO, we say, well, what parts of that need to be harmonized and what parts don't need to be? What's the stuff that we can forget about and let each state do it whatever way they want to? There are sometimes reasons for doing it harmonized, normally cost, safety, and often the need for harmonized procedures. But thank you very much, Doug. Much appreciated. The next presenter is Mike Lissone. Mike Lissone from Eurocontrol. He started off his career in military ATC and civil military coordination. He then progressed through Eurocontrol, involved in a number of projects in Sense and Avoid and airspace design, and he became the RPAS integration manager at Eurocontrol. He's also the Eurocontrol member on the RPAS panel, and he chairs the ATM integration working group 6, quite a thankless task, I imagine. So introducing Mike Lissone. Thank you, Mike.
Good morning, everybody. Thanks very much, and thanks, Chris, for setting the scene. ATM integration. I would basically want to bring it back to IFR integration and more related to actually what we're doing in the RPAS panel as much. Looking at the high-level ATM aspects, we want global harmonization as such. We have a vision for high performance, increasing capacity, being more efficient, reducing the cost, and also being more safe. Contradictions in terms already there. And already this is a big task for basically the demand that is coming there. And then of course around the corner, we also have RPAS coming along. So this is a big challenge we're looking at. So what I would like to do now is have a look at 4 of the main elements that are there. Detect and avoid, the silver bullet that most people talk about, the C2 link, the aircraft performance as such, and the contingency procedures. We have heard before of the other presentations, we are living in very interesting times. We are in the middle, like I said on Monday, of an industrial revolution where we are basically have an onslaught of new technologies and innovations coming our way, new business cases, and we're trying to keep up pace on that side. But it also opens the door to have a very critical look in how we're doing ATM as we're doing it now. We are perceived being very safe, looking at the numbers, that is totally correct. But looking very carefully at the pure being of detect and avoid, then we might be honest about the see and avoid issue, specifically looking at the VFR part. There is room for improvement. So what are we doing now? I hope it works. Simply what we're doing now is accommodation. This is a very old animation I'd basically bring out again because you probably have forgotten about it. This is allowing an aircraft, an RPAS, to fly from Germany to Belgium. We have increased the separation standards vertically and horizontally to allow it to fly. All the aircraft popping up in red are the ones that are penalized. Not able to continue the climb, continue the descent, or have to be radar vectored outside this bubble around this RPAS. This is an RPAS of the same performance, speed and turn performance you would normally have in a transport aircraft, but it shows you this is what's happening now. And why is it possible? Because we're not talking about large amounts and large numbers. But this is not the solution, of course. This is accommodating things. We want to integrate them and go back to the normal separation standards. 11 aircraft were penalized on this very short flight. Detect and avoid, the silver bullet, by itself very interesting. It's going to be, like Doug already said, going to be very interesting to have this capability there. Affordable, and it will change a lot of things in manned aviation as well. For the work within the group, it's a quantification of system performance. It's never done before. Think about remaining well clear. I know there's a lot of work being done already in the US, but these are the challenges we're facing in the panel over and over again. Trying to quantify things that have been done by good airmanship. We have to match see and avoid. I already talked about the VFR part, and I can only talk about Europe. See and avoid for VFR is not that very good. Huge amount of flyers from IFALPA, IOPA to teach people to scan better. And we have a lot of incidents in Europe on the VFR side. And if you reverse engineer it, you might ask, are we capable of flying VFR again? So that is a part we need to improve. And also the automated response during the C2 link. It is on one hand very interesting and on the other hand also very scary. The C2 data link, of course, the spectrum part, will we have enough spectrum to accommodate these issues? The required link performance, so what do we need from this link to be robust? We want it 99% of the time, which is probably not possible, which already raises a big question how we're going to do this. And then the latency issues. The required comms performance is now brought in for the oceanic part in RP10. Do we need to bring a required comms performance in for en route? In a radar environment, in terminal airspace. If you have a very busy sector with a lot of interactions, you want people to react immediately. And you cannot have somebody in there with an extended latency part. The integration challenge is also for the concept of operations we made for Europe. We have basically put up additional performance requirements for flying the network or the NAS. So if you want to fly with the 737s and the A320s, you will have to meet the same requirements. Otherwise the impact on the efficiency and the latency parts in the delays inside the system will be tremendous. So you have to think about the turn performance, climb, descent speeds. It's going to be interesting. Last but not least, that's the part we are working in, our working group 6, are the contingency procedures. We would like them to be harmonized. We would like them to be predictable. We would like them to be automatic, and also on that side to be published on that side. With Doug, he's in the group as well, we said we've drafted the first draft SARPs on this, very high level, and basically more like a vision how we would like to see it. But this is a very long journey that we have to find out. And there are many, many obstacles to be found. Just think about the fact that if you are departing from an airport, you lose the link and you'll have to go to the hold. Do you want this RPAS to go into the hold with an automatic response to detect and avoid, with aircraft descending inside this hold, where you have no real view what is going to happen on that part? Do you want them to go into a specific RPAS hold? Then the question would be, is there enough airspace to basically create this hold? Returning to the base, what changes if the runway changes? Are there obstacles on the runway? So you can see we have quite a journey ahead to find a good answer for these contingency procedures. But from the ATCO perspective, it has to be one way all. We can't have 20 different contingency procedures. It's simply not workable. So what's happening? It's also the last slide. The SARPS development, a huge amount of effort is going in there. Looking at my fellow colleagues of the RPAS panel, we're all sharing the same burden. Looking at Leslie, it's quite a challenge, but it's a lot of work that needs to be done. The draft contingency procedures are there. We're going to be presented at the next panel meeting. From a European perspective, we're trying to share as much as possible lessons learned and best practices. Because facing this, it is not rocket science. Is it complex? Yes, but it is not rocket science. It's very basic. But we need to create a level playing field and a common understanding. Already mentioned before, this is the most important part that is there. Share the lessons learned and the best practices. There is no need to reinvent the wheel. But then sometimes, especially for Europe, we are quite united in our division. I didn't say that, by the way. It will create a better understanding on the challenges, and the challenges they are, but it's also quite interesting to follow them. The progress for the RPAS part, we are still on track, but you saw on Monday that 18 of the 19 annexes are impacted on this. So this basically requires a tremendous coordination effort, not only within the panel itself, but also with the other panels. It impacts on their working schedules, and trying to make that work is the challenge that Mike has and Leslie has on that side, and all of us there. It is challenging and it's difficult. And also this symposium, this is a very good platform to share these lessons learned and the best practices, and to bring up the questions, and to discuss, and to agree, or to wholeheartedly agree to disagree. Thank you very much.
Thanks, Mike. United in our division. Very good. I might use that one often. My last speaker this morning is Captain Anthony Jim Parler. He's the Unmanned Aircraft System Project Lead in the Aircraft Design and Operations Group within the Air Safety Organization of ALPA. That's the US Airline Pilots Association. He also acts as an advisor to the member for IFALPA on RPAS. He's got a number of type ratings. He's currently a Boeing 757 pilot for FedEx. But the most interesting thing, and why I wouldn't mind going and having a drink with him, is that he's a US Navy Global Hawk pilot and operations manager, or was, sorry, with Northrop Grumman. He was responsible for the day-to-day operations and safety of real-world high-altitude reconnaissance missions as part of the Broad Area Maritime Surveillance Demonstration Program. So, an interesting person. Looking forward to your presentation. Welcome, Jim.
Thank you, Chris. And I'll be happy to have a beer with you if you're buying.
Okay.
Yes. As you can tell from my bio, my aviation career has taken some twists and turns, so I've gotten the privilege of being able to fly both manned and unmanned aircraft. And because of that, I became a subject matter expert on RPAS for IFALPA. And again, thank you for the opportunity to speak to you today on IFALPA's views on the introduction of RPAS into the air traffic management system. Well, look at that, it works. Okay, real quick, at the end of World War II, there was a growing recognition that the international cooperation was critical to ensure aviation safety. And subsequent years, as flights grew longer and aviation spanned the globe, the need for better coordination also grew and eventually led to the creation of ICAO. Pilots associations around the world wanted to ensure the pilot's point of view on safety would be taken into account as new standards and recommended practices, or SARPs, were developed. As a result, IFALPA was formed, and it grew until now the largest non-governmental organization, or NGO, aviation safety organization in the world. We have 100 nation members representing over 100,000 professional flight crew. We are a permanent observer to the ICAO's Air Navigation Commission, and we are very active on numerous ICAO panels, including the current RPAS panel. Why IFALPA? Why is IFALPA involved in the integration of RPAS and an active member on the current? Our first mission in IFALPA is to promote the highest level of aviation safety worldwide and be a global advocate for the piloting profession. Anytime a new technology is introduced into the ATM system, it has the potential to increase risks to the users of that airspace. IFALPA wants to be involved in the rulemaking process to help mitigate those new risks. The aircraft flown by IFALPA pilots will share in the same airspace with future RPAs. As airspace users and stakeholders, we do not want RPAS integration into the ATM system to lower or degrade the level of safety in the shared airspace. The introduction of RPAS must be done in the safest way possible. We bring extensive experience and knowledge of the traditional airspace user to the RPAS panel. Our members have conducted flight operations in every part of the world, and this experience benefits the RPAS panel discussions, particularly in the Ops Working Group. Our pilot volunteers have highly diverse backgrounds that bring expertise into all facets of aviation, including safety, operations, and human factors. In May of this year, IFALPA released a position paper that highlighted our positions on the integration of RPAS into shared airspace. I would like to highlight several IFALPA positions that are relevant to the discussions on RPAS integration and its effect on the ATM system. IFALPA believes that all RPAS should be integrated into the common airspace. Accommodation should only be a temporary measure. Only one sky is available for all aviation operations that vary greatly in size and aircraft performance. The principle of integration required all aircraft to operate according to similar principles and a framework, which makes them compatible to the extent necessary. Airspace users that are unable to comply with these common practices are normally separated and kept clear of other traffic. These non-compliant airspace users receive services necessary to allow operations, a principle referred to as accommodation. This practice, however, reduces the capacity of non-segregated airspace and therefore should be limited. All efforts should be undertaken to transform accommodation into integration. IFALPA considers that it is unacceptable to change the rules and regulations for manned aviation in order to accommodate UAS integration. The regulations for manned aviation have been established over a long period of time based on experience and best practices. These regulations should only be changed to enhance safety. RPAS should be developed to follow these regulations without regards to changing regulations that put burdens on manned aviation. Every UAS should have at times a responsible person in command who is suitably trained and qualified with an independent safety mandate responsible for the safe operation of the flight or mission or task. It is an overriding principle in aviation today that every aircraft has one person who has the ultimate responsibility for the safe operation of that flight and ensures that it is conducted safely and in accordance with all applicable rules and regulations. With the introduction of RPAS, the remote pilot in command should have the same responsibilities and authority as the pilot of a manned aircraft. An approved full and transparent risk assessment should be completed, including the ATM piece, before an operation can be commenced. This will allow for the identification and mitigation of all known risks and hazards, including collision with manned aircraft. Operations should only be allowed after all threats have been properly mitigated to an acceptable level. Currently, IFALPA does not believe autonomous unmanned aircraft can be integrated into common airspace. Fully autonomous UAS operations that do not allow for any direct pilot intervention after takeoff should not be authorized. The remote piloted command must have the ability to respond to changing flight conditions in real time and depart from the rules and regulations in circumstance that render such a departure absolutely necessary in the interest of safety. Autonomous unmanned aircraft cannot comply with this premise and therefore should not be integrated into common airspace. Future civil RPAS operations in shared airspace should be fully integrated. This integration should be developed with safety of the airspace and other users in mind. It should not be rushed, but done in a methodical, crawl, walk, then run manner. An IFR RPAS should operate in the same manner as a manned aircraft. They should be subject to the same rules of the air that govern all aircraft use, that the airspace and other conducting similar flight operations. The command and control link is one new technology that must be developed and certified that will enable future RPAS IFR flight operations. The command and control link is the only way the remote pilot in command can monitor, direct, and manage the flight, including communicating and complying with aircraft or ATC instructions on a real-time basis. A robust, reliable, and secure C2 link is vital for the safe RPAS integration. Loss link must be an extreme rare event if the RPA is to be integrated into shared airspace. Well thought out loss link procedures and protocols need to be developed. Response times for the RPA must be the same as manned aircraft. Delays in ATC instructions or readbacks cannot be allowed. And of course, the command and control link must be secured against hijacking or spoofing. Another enabling technology that must be developed and certified is a detect and avoid system. This system will allow for RPAS to meet the requirements to see and avoid and remain well clear as required by the regulations. RPAS should be equipped with an approved detect and avoid system to remain well clear and avoid collisions at all times in all airspaces as required by the rules of the air. They should be equipped with an airborne collision and avoidance system that operates automatically in the event of a lost link. To wrap up and summarize, RPA ATC integration must move from accommodation to integration in the airspace, but it must be done in a crawl, walk, run approach, and only after a full risk assessment has been completed. There should be no new regulations for manned aircraft to accommodate RPAS, and there should be one remote piloted command for every RPAS. No autonomous flight operations. The command and control link must be reliable, secure, and loss link must be an extremely rare. RPAS must be equipped with a detect and avoid and collision avoidance system that operates even during a lost link event. Thank you for your time. I look forward to any questions and the discussions that follow.
Thank you very much, Mike. And thank you, every one of you, for some of the questions that are coming in. Really very much appreciated. I forgot what my train of thought was going to be there. I was going to say, well, a lot of questions from IFALPA, and all of them relevant. And I think there's something within the Secretariat of ICAO that we watch for at this early stage within our business, is whether or not a panel of experts or a group that's working on a particular matter wants to look at a problem, or do they wish to put it aside. So in respect to the questions that were just raised by Mike, I would... Jim. I knew it was Jim, sorry. Jim, Mike, your questions were good as well. In relation to Jim's questions, From my perspective, it's not a problem that if you as a community want to disregard one of those particular issues as a community. You think it's unimportant and you can move on. But over my years within this organization, the biggest hassle has been just putting that issue aside, putting it in the too hard basket. We'll leave that for next meeting. We don't need to deal with it today, because that problem will be asked in the Air Navigation Commission. It will be asked by states in the reply to a state-led request for comments on a proposal for amendment of the annexes. And if it isn't fixed by then, the Commission will bring it up again. And then when it goes to the ICAO Council, it might even be brought up in the ICAO Council. You have to deal with these big questions. And when I say deal with it, doesn't mean that you have to necessarily agree, but it has to be dealt with so that the Secretariat and ICAO has an answer for that particular issue. So bring your attention to that. One thing that I didn't say to the panel, when I direct a question to you, but if one of you, one of the other panelists also wants to answer it, just flick your eyebrows at me or something or other. Okay, so good. Okay, my first question at the moment is a direction to Mike, since I was just rude to you. And if you could be very specific in your answers, I would like examples if you can. So this question is one, will there be additional airspace requirements for this new entrant coming into our world? Will there be additional airspace requirements?
Thank you very much, George, for the question.
You're welcome.
Initially, the first answer will be no, because they have to fit into the ATM system, and that is basically the principles of the integration part. Looking at the elements like the contingency procedures, but also looking at separation standards and how they are basically derived at the moment, there might be additional requirements. If we are talking about the fact that we need a specific RPAS hold, that might require some additional design perspectives. But that's the part that we still need to validate, and that's also the part on the lessons learned, more specifically from the military perspective, because we already heard they have more than 4 million flight hours, or 4.3 million flight hours, Doug. And that is feedback that we need, because as usual, the military are much more advanced on that than we are in the civil side.
Thank you. Doug?
Thank you, Chris. Just one point, I guess, to go along with what Chris's comments were, and then with Mike's as well. Accommodation is not new to RPAS. Accommodation's been around a long time. As air traffic control, we've accommodated unique capabilities into the airspace systems globally for time immemorial. We have dealt with, had to flex, had to stretch to deal with accommodation. So I think we got to be very careful in trying to brand it as being off-nominal. Even though it's not standard, it still is something that the airspace system does routinely. Thank you.
Okay, and just while you've got the mic and just changing the subject a little bit, because you spoke about predictability and the new technology and data that's going to be available, but at the end of the day, a community is going to have to put a safety case in front of the regulator, and that's going to be a game changer. To what extent do you think the new players can come on and write a safety case that will be found acceptable by what I would call a traditional regulator?
Yeah. That's a great question, and I think that there's the rub. Implementation has always been the hard thing, and the difficulty with airspace integration in general has long been the fact, what do you do with your existing systems? So when we in the FAA moved from ground-based to satellite navigation, the plan initially was to go to move away from VORs and DMEs, those kinds of things, and deal strictly with sat-nav loss and loss. But we still have VORs and DMEs, 25 years later. So there's a part of our integration migration problem which has being able to let go of the past and move into the future in a clean manner where you can take full advantage of the technology that's coming. And that's part of the hard discussion that new users today, new entrants today have to make. You've got to accommodate the legacy aircraft, legacy navigation, surveillance, communication system, while at the same time move forward into the future. And there's got to be a way to be able to say at some point, let's have that dialogue. It's going to be safer here. Let's just move when we can. And that's always been the hard part of this discussion. It always will be.
Okay, pass your mic to Rob, please. So on the same subject, Rob, our recent experience that you and I have been working with is approval process, approval authorizations for PBCS, performance-based communications surveillance. I'm sort of intimating the regulators are struggling to get on board with a reasonably simple approval process. Maybe ATS providers are not used to approval processes. So are the regulators ready for this? They seem to be struggling already without even looking at RPAS.
Yeah, Chris, it's a good point, and Chris just used the example there of a new concept, performance-based communication surveillance, and the lack of knowledge and regulation or guidelines in place for states to certify. I'm actually going to go back, Chris, another 5 years, and just to give an indicator of some of the issues we're dealing with. If we talk about performance-based navigation, PBN, so basically the onboard navigation capabilities, moving towards generally a GNSS operation for navigation with huge safety and efficiency benefits for manned aviation. PBN is generally GNSS based, and 5-6 years ago, I think it was, we had a really big push in industry for the implementation of performance-based navigation for APV approaches with vertical guidance. And there's actually a General Assembly resolution in place, General Assembly Resolution, I think 37, for PBN implementation. Also, a resolution relating to states to have a PBN plan. Well, I think it's safe to say, and I think you've got better information from me, Chris, that we really fell short on this. And one of the principal reasons for that is because of the lack of capability, the lack of knowledge, and the lack of ability to certify operations of PBN by the regulators. To that end, to help address it, ICAO, IATA, and industry invested an awful lot of money going around the world doing workshops and education and buddy-buddy systems between states, but still we're falling seriously short. And that's PBN. So a huge consideration moving forward is the ability for regulators to understand, comprehend, approve, certify new operations from a technology and concept operations point of view. So we have all the scars and bruises and bite marks from what we've had to really wrestle with and get really upset about from manned aviation, and all of that angst can be used to give us an indicator of what we need to do, what industry needs to do, what ICAO needs to do, industry needs to do to help regulators. So it took quite a long time on responding to that, but I think it's a really important point, Chris.
Okay, thank you, and I'll come to Rob and Jim, but I just want to push this point a wee bit further, so I'll go back to Mike. I started on something called a concept on required communication performance when it was put on my work program in 1996. It's now in the books. We're struggling with some of the small points now in 2017. When do you think the first aircraft will be approved with RLP?
I can only basically make an equivalence to PRNAV in the time in PRNAV1.
I'm actually asking your ability at mathematics.
Mathematics?
Yes,
that will take a very long time. Mostly when we are ready to implement new technology is about 10 to 15 years old. That's how long it takes before we actually have all the paperwork.
Do you think the
ready.
community understands that? Do they understand that RLP won't happen before most of us are retired? In the formal sense, in the sense of working with regulators today, I'm asking whether or not do we need a whole new concept of how this would go forward?
Yes, I fully concur that. I think we need a complete new shake-up of the system and how we approach these things. For the time being, we're still stuck in an old-fashioned, with all respect, very conservative, very safe environment where everybody feels very quite safe to take a very long time. Very long time.
Thank you very much. Okay, very good, very good. And I'll take a question from the floor here. It's from an aerodromes guy, David Gamper, actually, which is very good. And so I'm going to direct this question at Jim. Is the comms with the remote pilot going to be rapid and reliable enough for flight critical situations during final approach at busy airports? There you go. You have to give him a mic there, Pete.
Names.
Well, they're going to have to be. I mean, it's just there. If there's any delays or any abnormal, unusual characteristics, it's not going to be accepted, particularly at busy airports, and they're going to be asked to, hold or come back when you can.
Okay, and just while you've got the mic, another question from the floor that's quite good. Tell us what your experiences have been with pilots that actually fly both manned aircraft and unmanned aircraft. Is there a downgrading in their professionalism? Is there an upgrading? Is there no relationship? Just tell us some of your experiences when you're talking to these pilots.
Well, my experience is when I was at Northrop Grumman and in charge of the Global Hawk pilot training programs there for the BAMS-D program, is that, and the General Atomics flight instructor yesterday said this, you really can't tell. There's just, you look at a guy, he comes in and on paper they're the same, and one guy can make the transition, one pilot can make the transition, and another can't. It really, the key point that I looked for was that, the situational awareness goes away when you've very much degraded when you're flying an RPAS with current technology. That you have all other senses are gone except for your visual inside on a screen. So you have to mentally put yourself on that aircraft that's sitting on a ramp. When I was an instructor, and taking my first students out, and they would go, okay, ready to taxi, and I'd like, oh, wait, what? You're got to call ground to get clearance. Oh yeah, that's right. It's a mental game. So that as for with the automated systems, obviously the pilot stick and rudder skills will degrade, and most programs have a requirement that they remain IFR proficient in a manned airplane.
Oh, we need to do that beer soon. Okay, that's very good. So, Rob,
I like expensive beer.
So, firstly, I just wanted to talk about, what are the biggest challenges to seamless integration from your perspective, and sort of, can you say it from the perspective of the GAMP, the Global Air Navigation Plan, and the ASBUs?
Thanks, Chris. Yeah, I think the current challenges are really for that accommodation of RPAS. If we're looking to integrate RPAS seamlessly as possible right now, then there's big technological, there's big procedural challenges to do that. But I think if we do look at the Global Air Navigation Plan, the ASBUs, and the way the ATM system is predicted to develop in line with next-gen, CISAR, carrots and other such systems, I think there is a natural convergence, and I think we've heard it here several times from my colleagues on the panel. There's a natural convergence between the way the ATM system is likely to develop with 4D trajectory management, for example, and the ability of RPAS and the requirements for them to be, within a data sharing environment. So I think it is particularly interesting, this idea of the transference of technology and procedures from RPAS into ATM, although I think they're, at the present time, naturally converging in line with the global plans anyway.
Okay, so nearly half the questions I've got from the floor are about autonomy, self-separation, and automation. So and this is, I'm not asking Doug. No, I'm not. Yeah, I know that was in your presentation. So you're not allowed to answer this question. So our ASBUs and the way we're moving forward is all about TBO. It's all about air traffic flow management. It's all about bigger picture. It's all about a flight plan of a flight that's going 17 hours now. Should we be, is autonomy, is self-separation going to play a major role in this game? or is it going to be an unnecessary part of what something is called air traffic management? Anyone? And by the way, we're not taping this. You can just give personal views. You won't be shot down.
Chris, I'll just give you a view. I think self-separation will play a role. Industry has identified a requirement for self-separation. If you go back whenever it was, I can't recall, 8-10 years when we were looking at ADS-B in-trail climbs through the Pacific for remote oceanic operations, and it became cost prohibitive primarily from the cockpit side. I think with as we go forward, we all know today that it's great fun to be in air traffic control. It's very tactical, turn left, turn right, et cetera, but we've reached the capacity that a human can safely manage. And to help offset workload and ensuring it's done safely, self-separation between aircraft should be looked upon as a positive. The questions about what airspace is appropriate can be done in is another interesting debate. The military have been doing safely self-separation for a couple of decades. So I think there's certainly yes, and all of the concepts that are being looked at for the lower altitude are looking at self-separation. So yes, certainly in some manner, done safely, no undue burden, manned aviation, no negative impact safety. Certainly.
Doug?
So, the issues were with the full prescription and full integration of self-determinism or self-separation like are being discussed are still relative to where we are as infrastructure and configuration in airspace system management and operations. So you've got to be able to provide potentially air navigation services, air traffic services for completely wooden aircraft with no electronics on board, all the way to sophisticated Part 25 aircraft that still today aren't allowed to use half of the equipment that are on board because the system can't handle it. So when you start talking about autonomy and self-separation, those are lofty ideas that have a tremendous amount of merit and should be pursued. The difficulty is in the how, again, it gets done and when you decide, which we as a global community, we tend to restrict like we did with RBSM. You know, there's a certain altitude block that, you know, if you're not equipped, you don't participate in it. And at some point in time, air navigation service providers are going to be faced with, okay, well, what do I have? I've got what kind of equipage operating in what kind of airspace and what kind of rules, what's my separation standards? Oh, that's right. It's a section where the pilots take care of it, so or the systems do, so I don't have to worry about it. It really is kind of dragging in the whole inability to be able to focus on one common infrastructure into the market space, and that's where I think the issue is with this.
Okay, thank you. We're slowly coming to the end of our question and answer period, so I'd just like to go back to Jim. A question from the floor again. You mentioned that there should be a policy of one pilot, one aircraft. Is that being a wee bit inflexible when we consider there could be clusters of aircraft flying at very high altitude under certain circumstances?
Yeah, that is being inflexible, but when every aircraft can have in-flight emergencies, and if you have multiple, how is that going to be handled? Equipment breaks, stuff happens, bad weather happens. The system today is designed for one pilot, one airplane, and until there's advances in artificial intelligence that make it okay, then maybe. But right now, the system is designed for a human in the loop or on the loop to make the decisions. And so that's the way we see it.
Right.
And just to add to that, relating to my comments on the legal implications and particularly the duty of care, you know, it's pilots and controllers who ultimately are still going to have some legal liability here, and I think we do really need to explore the impacts of RPAS on that, on the individuals concerned. I mean, the pilot in command has the ultimate responsibility for the aircraft, and I think it's really interesting to think that that actually still applies even if you have a lost link and the aircraft itself is perhaps technically out of control. The legal, as far as we know, the legal liability still stops with the pilot in command. So I think we really do need to engage within our states, our prosecutors, our judiciary, our legal experts, to try and get to the bottom of this particular aspect for RPAS, for the sake of the operational community.
So thank you, Rob. And let's be honest, we could have gone on for another hour and a half, if not the rest of the day. So my thanks to you. I actually want to finish with a comment that was received from you, from a certain Mr. James Dow. James Dow. Oh, Jim Dow. And it's a really nice comment, so I'm going to read it. As we explore questions of what RPAS means to the ATM environment and to the aviation system, we do well to remember that we have seen the rise of new technology challenge international civil aviation before. An early example is seen in ICAO Circular 23. Problems associated with the advent of turbine-engined airplanes. That technological change touched most of the annexes to the convention and impacted the ATM environment and the whole aviation system. Before the circular, there was an IATA Turbine-Engined Aircraft Symposium, 18 and 19 of May 1950. That was a long time ago, but just as we are doing today, they asked all the questions and they found the answers together. I'd like to thank my panelists. You've done a great job. I'd work with you again anytime, and I had a great pleasure in working with you. Thank you very much. Thank you.
Wait. They don't get off the hook quite that quickly and easily. Disrupting things already. So I want to add my thanks to Chris as well, Chris and the panelists, and just to point out again that each one of these panelists participates in the RPAS panel. So you can get an idea of the caliber of people with their expertise, their long experience, the kind of questions that they raise in the panel, and their dedication to looking for solutions to all those questions. So this is just a small taste of what we have in the RPAS panel, and also to an extent in the UAS advisory group. So thank you for that. So it is time for coffee break, and I'd kindly ask the audience to return here to the Assembly Hall in time for us to resume promptly at 11 o'clock. Moderator and panelists in the next session, if you would, please come back just a few minutes before then. Thanks, and go have a good coffee or tea.